Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 4.3.6, Symmetric Groups. Um, so, remember how we talked about permutations and cycle notation? Let's suppose that we take a look at all the permutations on a group, on a collection of three things, 1, 2, and 3, just literally those numbers, 1, 2, and 3, and we can think about the different permutations and cycle notation this way, and with composition, we have a group. Notice that in each column, you have the identity permutation, which means do nothing, and in each row, you have it exactly once. That means that everything has an inverse, and this is composition of functions. Composition is associative. We have an associative operation. Notice it's also closed. You have one permutation followed by another, you get another permutation. So it's associative, it has an identity, it has inverses, and it's a closed operation. We end up getting a group. So here, just a little tidbit on reading this table. So okay, so we go on the left. So in order, we do this. So we take what's on the left, okay, of computation, and what is the top header row on the right in the computation. So 1, 3, 2, and 2, 3, or something like that. In order, so with this composition, so write this one on the left, write that one on the right. Okay. So the identity function is associative. Okay, so here, this is just a little description of that. This is just something you can look at if you want to later. But essentially, any finite group actually ends up being a subgroup of one of these. At least structurally, it looks like that. That's called an isomorphism because the group structure is actually preserved, even though the operation might look different. But and sometimes this guy has to be really big, this group, maybe with a lot of things you're permuting, but really any finite group can actually be thought of as a subgroup of a permutation group. Thanks for watching.